Electrical enclosures do not need to be dust-tight or dust ignition-proof if the machine is properly aspirated. Aspiration systems remove dust from the surrounding area, reducing the risk of dust accumulation and ignition. However, electrical enclosures must be dust-tight or dust ignition-proof if the machine does not have an adequate aspiration system. NEMA 12 enclosures are not considered dust-tight. They provide protection against dust, dirt, and falling debris, but they are not designed to prevent the ingress of fine fly or dust. For fly or packing facilities, it is recommended to use electrical enclosures rated NEMA 4 or higher, which provide a higher level of protection against dust and water ingress. Fly or dust is a combustible material, so proper ventilation and electrical equipment maintenance are crucial to prevent explosions. Electrical enclosures must be properly grounded to prevent the accumulation of static electricity, which could ignite fly or dust. Furthermore, regularly clean the surrounding area and electrical enclosures to remove dust accumulation. Considering explosion prevention, understand that fly or dust is indeed a combustible material. Proper ventilation and diligent electrical equipment maintenance are essential to prevent explosions in environments where fly or dust is present. Ensure that ventilation systems are functioning correctly to minimize the concentration of airborne fly or dust. Regularly inspect and maintain electrical equipment to identify and address any potential ignition sources. Regarding grounding, remember that electrical enclosures must be properly grounded to prevent the accumulation of static electricity. Static discharge can act as an ignition source for fly or dust, so grounding is a critical safety measure. Verify that all electrical enclosures are connected to a reliable grounding system. Periodically inspect grounding connections to ensure their integrity and effectiveness. About regular cleaning, it is paramount to regularly clean the surrounding area and electrical enclosures to remove dust accumulation. Fire or dust accumulation poses a significant fire and explosion hazard. Implement a routine cleaning schedule to remove dust from surfaces, equipment, and enclosures. Use appropriate cleaning methods and equipment to avoid creating dust clouds during cleaning. So to reiterate, aspirated machines may not need dust-tight enclosures, but non-aspirated machines will need dust-tight or dust ignition-proof enclosures. Furthermore, NEMA 12 enclosures are not considered dust-tight, but NEMA 4 or higher are recommended. Grounding, regular cleaning, and explosion prevention should also be kept in mind at all times. Aspiration systems are designed to capture and remove airborne dust particles, preventing them from accumulating on surfaces or entering electrical enclosures. Proper aspiration reduces the risk of dust explosions and electrical hazards. Ensure that the aspiration system is correctly sized and maintained to effectively control dust levels. Dust-tight enclosures are designed to prevent the ingress of dust particles, protecting internal electrical components from contamination. These enclosures are typically used in environments with high dust concentrations where dust accumulation could lead to equipment malfunction or failure. Dust ignition-proof enclosures are designed to contain an internal explosion of dust and prevent the propagation of the explosion to the surrounding environment. These enclosures are used in areas where there is a high risk of dust explosions. NEMA, which stands for National Electrical Manufacturers Association, ratings define the types and severity of environmental conditions that an enclosure can withstand. NEMA ratings are used to classify enclosures based on their ability to protect against dust, water, corrosion, and other environmental factors. NEMA 4 enclosures are designed to provide protection against splashing water, hose-directed water, and the ingress of solid foreign objects, such as dust and dirt. These enclosures are commonly used in food processing plants, dairies, and breweries. NEMA 4X enclosures offer the same level of protection as NEMA 4 enclosures but are also corrosion resistant. These enclosures are typically used in environments with corrosive chemicals or saltwater. In addition to the enclosure rating, consider other factors when selecting electrical enclosures for fly or packing facilities. These factors include the size and type of electrical components being housed, the operating temperature range, and the presence of any corrosive substances. Consult with a qualified electrical engineer to determine the most appropriate enclosure for your specific application. Remember that the primary purpose of explosion prevention measures is to minimize the risk of dust explosions. Fire or dust explosions can be devastating, causing significant damage to property and potentially resulting in injuries or fatalities. Implement comprehensive explosion prevention strategies, including ventilation, dust collection, and enclosure selection, to create a safe working environment. Grounding helps to dissipate static electricity, preventing the buildup of charge that could lead to a spark. Static sparks can ignite fire or dust, causing a fire or explosion. Ensure that all electrical equipment and enclosures are properly grounded to provide a safe path for static electricity to discharge. Develop a regular cleaning schedule to remove accumulated fire or dust from surfaces, equipment, and enclosures. Use appropriate cleaning methods, such as vacuuming or wiping down surfaces, to avoid creating dust clouds. Dust clouds can increase the risk of dust explosions. Train employees on proper cleaning procedures and the importance of maintaining a clean working environment. Aspiration systems work by creating a negative pressure that draws dust particles away from the source and into a collection system. The collection system typically consists of a filter or cyclone that removes the dust particles from the air. Ensure that the aspiration system is properly designed and maintained to effectively capture and remove dust. Dust-tight enclosures are constructed with gaskets or seals that prevent dust from entering the enclosure. These enclosures are typically tested to ensure that they meet specific dust tightness standards. Consider using dust-tight enclosures in areas where dust accumulation is a significant concern. Dust ignition-proof enclosures are designed to contain an internal explosion without allowing flames or hot gases to escape into the surrounding environment. These enclosures are typically constructed of heavy-duty materials and are designed to withstand high pressures. Dust ignition-proof enclosures are required in areas where there is a high risk of dust explosions, such as grain elevators and flour mills. Different NEMA enclosure types offer varying levels of protection against environmental hazards. Select the appropriate NEMA enclosure type based on the specific environmental conditions present in a flour packing facility. Refer to NEMA standards for detailed information on the protection provided by different NEMA enclosure types. In addition to selecting the appropriate enclosure rating, ensure that the enclosures are properly installed and maintained. Follow manufacturer's instructions for installation and maintenance to ensure that the enclosures provide the intended level of protection. Regularly inspect enclosures for damage or deterioration and repair or replace them as needed. Consider the potential for water ingress when selecting electrical enclosures. If the enclosures are likely to be exposed to water, select enclosures with a NEMA rating that provides protection against water ingress, such as NEMA 4 or NEMA 4X. Water can damage electrical components and increase the risk of electrical hazards. In environments with corrosive substances, select enclosures made of corrosion-resistant materials, such as stainless steel or fiberglass. Corrosive substances can damage enclosures and compromise their protective capabilities. Regularly inspect enclosures for signs of corrosion and replace them as needed. Consider the operating temperature range when selecting electrical enclosures. Ensure that the enclosures are rated for the temperature range in which they will be used. Extreme temperatures can affect the performance and lifespan of electrical components. Follow all applicable electrical codes and regulations when installing and maintaining electrical enclosures. Electrical codes and regulations provide guidelines for safe electrical practices and help to prevent electrical hazards. Consult with a qualified electrical inspector to ensure that all electrical installations meet code requirements. Provide employees with training on electrical safety and the proper use of electrical equipment. Training can help employees to identify and avoid electrical hazards. Regularly review and update training programs to ensure that employees are up to date on the latest safety practices. Remember that electrical safety is a shared responsibility. By implementing appropriate safety measures and following safe work practices, you can help to prevent electrical accidents and injuries. Properly designed aspiration systems effectively capture and remove dust particles, reducing the need for extremely robust enclosures. When an aspiration system is in place, the concentration of airborne dust is significantly reduced, minimizing the risk of dust accumulation within electrical enclosures. This allows for the use of enclosures with lower NEMA ratings, such as NEMA 12, which provide adequate protection against dust, dirt, and falling debris but are not necessarily dust-tight. However, it is crucial to ensure that the aspiration system is functioning correctly and is regularly maintained to prevent dust from accumulating in the surrounding area. Regular maintenance should include inspections, filter changes, and repairs as needed. Without a properly functioning aspiration system, the concentration of airborne dust can increase significantly, requiring the use of dust-tight or dust-ignition-proof enclosures to protect electrical components from contamination and prevent potential explosions. Dust-tight enclosures are designed to prevent the ingress of dust particles, ensuring that sensitive electrical components remain clean and functional. These enclosures are typically constructed with gaskets or seals that create a tight barrier against dust. Dust-ignition-proof enclosures, on the other hand, are designed to contain an internal explosion of dust and prevent the propagation of the explosion to the surrounding environment. These enclosures are typically constructed of heavy-duty materials and are designed to withstand high pressures. Choice between dust-tight and dust-ignition-proof enclosures depends on the specific risks associated with the fly or dust in the facility. If the risk of dust explosions is high, dust-ignition-proof enclosures are recommended. If the risk of dust explosions is low but dust accumulation is a concern, dust-tight enclosures may be sufficient. NEMA 12 enclosures provide a good level of protection against dust, dirt, and falling debris but are not designed to prevent the ingress of fine fly or dust. These enclosures are typically used in environments where dust is present but not in high concentrations. NEMA 4 enclosures, on the other hand, provide a higher level of protection against dust and water ingress. These enclosures are designed to be dust-tight and can withstand hose-directed water. NEMA 4X enclosures offer the same level of protection as NEMA 4 enclosures but are also corrosion-resistant. In fly or packing facilities, where dust is a significant concern, NEMA 4 or higher enclosures are generally recommended. These enclosures provide adequate protection against dust accumulation and can help to prevent electrical problems. In addition to the enclosure rating, consider other factors when selecting electrical enclosures for fly or packing facilities. These factors include the size and type of electrical components being housed, the operating temperature range, and the presence of any corrosive substances. Consult with a qualified electrical engineer to determine the most appropriate enclosure for your specific application. Remember that the primary purpose of explosion prevention measures is to minimize the risk of dust explosions. Fly or dust explosions can be devastating, causing significant damage to property and potentially resulting in injuries or fatalities. Implement comprehensive explosion prevention strategies, including ventilation, dust collection, and enclosure selection, to create a safe working environment. Grounding helps to dissipate static electricity, preventing the buildup of charge that could lead to a spark. Static sparks can ignite fly or dust, causing a fire or explosion. Ensure that all electrical equipment and enclosures are properly grounded to provide a safe path for static electricity to discharge. Develop a regular cleaning schedule to remove accumulated fly or dust from surfaces, equipment, and enclosures. Use appropriate cleaning methods such as vacuuming or wiping down surfaces to avoid creating dust clouds. Dust clouds can increase the risk of dust explosions. Train employees on proper cleaning procedures and the importance of maintaining a clean working environment. To summarize, the presence of a well-maintained aspiration system can reduce the need for dust-tight or dust-ignition-proof enclosures. However, in the absence of an adequate aspiration system, these enclosures are essential to protect electrical components and prevent potential explosions. NEMA 12 enclosures are not considered dust-tight, and NEMA 4 or higher enclosures are generally recommended for fly or packing facilities. Additional safety measures, such as grounding, regular cleaning, and explosion prevention strategies are also crucial to ensure a safe working environment. Remember to consult with a qualified electrical engineer to determine the most appropriate enclosure for your specific application. Proper grounding is a critical safety measure in fly or packing facilities due to the combustible nature of fly or dust. Fly or dust can easily ignite and cause explosions if exposed to a source of ignition, such as a static spark. Grounding helps to prevent the accumulation of static electricity, which can create sparks and ignite fire dust. Electrical enclosures, equipment, and machinery must be properly grounded to provide a safe path for static electricity to discharge. The grounding system should be regularly inspected and tested to ensure its effectiveness. Grounding conductors should be properly sized and connected to a grounding electrode system that meets applicable electrical codes and standards, such as those outlined by the National Electrical Code, or NEC. The NEC provides specific requirements for grounding electrical systems and equipment to ensure safety. Proper grounding practices are essential to minimize the risk of static electricity buildup and prevent potential explosions in fly packing facilities. Regular cleaning is another essential safety measure in fly packing facilities to prevent the accumulation of fly dust. Fly dust can accumulate on surfaces, equipment, and enclosures, creating a fire and explosion hazard. Regular cleaning helps to remove dust and minimize the risk of ignition. A comprehensive cleaning schedule should be implemented to ensure that all areas of the facility are cleaned regularly. Cleaning methods should be carefully chosen to avoid creating dust clouds, which can increase the risk of explosions. Vacuuming or wiping down surfaces with a damp cloth are preferred cleaning methods. Compressed air should be avoided, as it can create dust clouds. Employees should be trained on proper cleaning procedures and the importance of maintaining a clean working environment. Regular cleaning practices are essential to prevent the accumulation of fly dust and minimize the risk of fire and explosion in fly packing facilities. Explosion prevention strategies are crucial in fly packing facilities to mitigate the risk of dust explosions. Fly dust explosions can be devastating, causing significant damage to property and potentially resulting in injuries or fatalities. A comprehensive explosion prevention strategy should include a combination of measures to prevent dust accumulation, control ignition sources, and minimize the consequences of an explosion. Ventilation systems should be designed to remove airborne dust particles and prevent the buildup of dust concentrations. Dust collection systems should be used to capture dust at its source and prevent it from spreading throughout the facility. Explosion venting should be provided to relieve pressure in the event of an explosion and prevent structural damage. Spark detection and suppression systems can be used to detect and suppress sparks before they can ignite fly dust. Explosion-resistant equipment and construction material should be used to minimize the damage caused by an explosion. A comprehensive explosion prevention strategy is essential to mitigate the risk of dust explosions and ensure the safety of personnel and property in fly packing facilities. It is important to consult with qualified engineers and safety professionals to develop and implement an effective explosion prevention strategy that meets the specific needs of the facility.